Hello students, hope you are doing well and you are also studying well during this unblock. Welcome to this video. So we'll go for the next concept today. So before we begin with today's concept, let me quickly revise what we had spoken about in the last video. So in the last couple of videos we had seen how to calculate mean deviation and how mean deviation is different than quartile deviation and what is the meaning of coefficient of mean deviation. Now look at this example. This is again the same example we had discussed already. So this is the graph of x values along with versus frequency values. So the central measure of tendency for both of them is same. So the arithmetic mean, median, mode, all three of them will be in the same range of this, because these two are, though they are having the different spread or the dispersion is different, but the central part which is concentrated is same for both of them. So in the case of quartile deviations, it can still have the effect only on the central part. And in the case of mean deviation, that will help you to understand how values are dispersed from the mean, how values are, how far the values or how near the values compared to the mean. But then again, in mean deviation, we do neglect the negative signs. So though negative signs we neglect and we find the deviations, but that really did not give you, or it will not tell about the disperse of the elements throughout this mean. So we have new measure of dispersion called as the famous standard deviation. Standard deviation takes into account all the observations in the entire distribution, and for every observations or every class, the deviations is actually considered as it is. So standard deviation is considering also their signs, so deviations whether it is on right side or left side, and this gives us the measure. So this is one standard measure to understand the disperse or the spread of the values and how it is and how it is away from the mean on both the sides. So standard deviation is one such very standard measure to understand the spread of all the values. So now have a look on one example. Suppose we have given two series. So this is one series and another series is 12, 14, 16, 18, and one series we have 4, 6, 22 and 28. Okay, so now the arithmetic mean for them we will calculate. So this gives me summation 60 and we have got elements 4. So this gives me arithmetic mean for this is 15. So if you consider 15, it can nowhere relate with any one of these values. Okay, but then again you would say that data set 1 has got arithmetic mean 15, and in this case this is also 15. So arithmetic mean for this also 15. At least these two values are near to 15 as compared to these two. Alright. So these two are at the equal distance from the 15 on both the sides. Same for these two as well. So now 15 with the meaning of arithmetic mean, which can replace most of the values in the distribution. So here, only for this example it holds good, but not for this example. But the arithmetic mean value what you are getting for both the data sets is same, but the deviations in their values is very different. Now if we calculate the standard deviation for this same data set, then we can expect some change, or we can expect the standard deviation would be different for both of this. Then that would be the correct measure to compare such two data sets. So standard deviation is also denoted by this symbol called as sigma, and it is given as the square root of square summation of the squares of the deviations from the arithmetic mean divided by the total frequency. So this is how the standard deviation is given. It is the squares, summation of the squares of the deviations from the arithmetic mean divided by the number of frequency. I mean the total number of frequency. So if it is a grouped data, or it is the discrete data or group data along with its frequency, only the thing is like this standard deviation is again the square root of then summation of frequency into squares of their deviations divided by n. So this is the only difference we have in the formula. Alright, now we will use the same formula to calculate standard deviation for these two. Anyways, for both of them the arithmetic mean is 15. So the deviations would be here. Yes, these will be the deviations from the mean. Okay, and then for this one, deviations would be -3, -2, 1 and then 3. Sorry, -3, 1, -1, 1 and then 3. Then we need to find their squares. So squares of negatives are always positive. And for this one it is, so this summation of the squares is 20 here, and in this case 420. Okay, then as per this formula, so square root of 20 divided by 4, so that gives me square root of 5. So square root of 5 would be 2 is the square root of 4 and 3 is the square root of 9. So that would be in between 2 and 3, maybe 2 point something, say 2.4 and then something. That would be the square root of 5, and in this case it is square root of 15, so that would be 3.8 or something. So the standard deviation values are here this way. The dataset 1 has got 3.8 and dataset 2 has got standard deviation 2.4. So the meaning is that first dataset is having more deviations from the arithmetic mean as compared to the second dataset. So in the second data set, we say that there is a standard deviation of 2.4. That means most of the values are in between arithmetic mean minus 2.4 to arithmetic mean plus 2.4. This is the indirect meaning of the standard deviation. So same for the data set 1, and for data set 1 that spread is more. I mean the deviations are more as compared to data set 2. So that's why you can say the standard deviation gives you the measure of spread or the measure of deviations from the arithmetic mean. So standard deviation is basically with the arithmetic mean, but like mean deviation we calculate in the considering the arithmetic mean or median. But standard deviation always is calculated using the arithmetic mean. So we'll take some examples to solve arithmetic mean. So basically these two data sets are having same arithmetic mean, but the standard deviations are different. And that shows how these values are fluctuated or deviated from the arithmetic. Alright. So these two examples we have, this is the discrete data and that is continuous data. Both of them are given frequency. So the first thing we need to calculate is the arithmetic mean for both of them. For after calculating arithmetic mean, we have to calculate the deviations, then square them. After squaring, we have to multiply with the frequencies, and then the summation has to be divided by the number of frequency, and whose square root has to be taken to find the standard deviation. So first let me calculate the arithmetic mean of this. So it's a discrete data, so I have to just add all of them. So the frequency summation is 100. Okay. So now I have to calculate fx here. So the multiplications of frequency along with x is done. So summation of this we have calculated is 1500, and then divided by the total number of frequency. So 15 is the arithmetic mean we have received. Okay, now we have to calculate the deviations from the arithmetic mean. So 15 is the arithmetic mean. So deviations from the arithmetic mean. So once you have calculated the deviations from the arithmetic mean, we have to square them. So squaring is this way. Then this squared all these deviations which are we have squared, those we need to multiply with the frequency. So f into x minus x bar the whole square. This is what we need to calculate. So this frequency we have to multiply here. Okay. Now the summation of them, summation of this column is 304. So as per our formula, it is the square root of summation of frequency multiplied with the squares of all deviations, which is 304 divided by 100. That is the summation of all frequencies. So 304 by 100 gives you 3.04, and its square root we need to calculate. So your standard deviation would be, so it would be 1 point something, specifically 1.7 something. So your standard deviation would be 1.7. So which is very minimum value. So you can still say the items in this particular distributions are more towards the arithmetic mean. Okay, so considering the central frequency part, right, starting from 13 to 17, or you can say 13 to 16, the higher frequencies are 11, 32, 21, 15. These are contributing more into the entire distribution, and they are again towards arithmetic mean. And even the same thing, our calculation tells that the standard deviation is almost minimum. So in the entire values, most of the values of the entire distribution are in the range 1.7, arithmetic mean minus 1.7 to arithmetic mean plus 1.7. Now in the similar way, we have to also calculate the standard deviation for this example. Now this example is little different. Here the group data is given, I mean the continuous data is given along with the frequencies. Okay, so first thing is we need to calculate the midpoints for all the classes. So let me add a column called as here M, and then midpoints are here, all are even midpoints. So all midpoints are ready. Then we have to multiply these midpoints with frequency. So once we have done with calculating the frequency into the midpoint, so we have to add all these frequency into midpoint summation, and then we have to add all the frequencies that will give us the arithmetic mean. So this gives me 800 is the summation of frequencies into the midpoints. And this gives me 100. So our arithmetic mean is very much clear. So we have calculated the arithmetic mean, which is 8. Now considering this arithmetic mean 8, we have to calculate the deviations of all these midpoints along with this mean. So let me add a column called as here x minus x bar. So x bar we have calculated is 8. And this is our midpoint, that is nothing but x. So we have to calculate the deviations. So this gives me minus 6, minus 4, minus 2, 0, 2, 4, and then 6. Okay, we have got the symmetrical deviations here. Then the squares of all of them. So after squaring the deviations, we get here 36, then 16, then 4, 0, 4, 16, and then 36. Now these squared deviations we have to multiply again with their frequencies. So f into x minus x dash the whole square. So this I need to multiply with the frequency. This 16. Then this 4 into 25, this gives me 0. Then this 4 into 17, then this 16 into 10, and then last this 36 into 3. So we are done with multiplying all the frequencies with their squared deviations. Now let me calculate sum of these all. So what we have calculated is 616, and our frequency summation is already calculated, which is 100. So as per our formula of standard deviation, it is the square root of 616 divided by 100. So this is nothing but the square root of 6.16. So square root of 6.16 would be 2 point something. So let me calculate. So it gives me 2.4 will be the value of standard deviation for this data set. So for this grouped data, we have to first calculate arithmetic mean by using the normal method, then calculate the deviations from the arithmetic mean. The deviations we have to square, and the squared deviations has to be multiplied with the frequencies. So it is the similar method we have. So everywhere it is the deviations has to be calculated and deviation has to be squared. So this is a very different technique we have used in in standard deviation. So standard deviations are not like mean deviation. First thing, in mean deviation, we calculate only the deviations and we don't consider the negative deviations or the deviations where we have negative sign. But in standard deviation, we calculate the deviations and those deviations are squared, and after squaring multiplied with the frequency, and then ultimately we find the square root of this ratio where we have summation of the squared deviations multiplied with frequency and divided by the total number of items. Now if you consider, or if you compare these two data sets, the first one is discrete one, and in the discrete data set we have got the standard deviation 1.7, and the second one we have got it as 2.4. So if you compare these two data sets, so it is very much clear that in the first data set most of the values are near to the arithmetic mean as compared to the second data set. Though it is group data, so the standard deviation is 2.4, so most of the values are concentrated. How they are concentrated from arithmetic mean minus 2.4 to arithmetic mean plus 2.4. So indirectly it is like the arithmetic mean we have got is 8. So 8 minus 2.4 would be 6.6, and then plus 2.4 would be 10.4. So most of the values are from 6.6 to 10.4. So if you consider that part, then if you consider the frequencies, that will give you 25, 35 and 17. That is the central part, and in the central part how these values are concentrated, that is the measure of standard deviation. So same thing is applicable there also. So their values are more concentrated as compared to the class group data for this example. As compared to the previous example, more values are concentrated near arithmetic mean by the mean of standard deviation value. So this is how you compare two data sets using the standard deviation value. So hope you have understood this example. So similar such examples you try to solve on your own and compare the values of standard deviation for the different kind of data, and also solve the examples given in the notes. So along with this method, how do we have the method of arithmetic mean, which we call by using assumed mean method, that is called as the shortcut method for arithmetic mean. Similarly, we also have the shortcut method of calculating standard deviation. So that we'll be discussing in the next video. So till then, take care of yourself, also take care of your family members. So though it is unlocked, study well and follow all the guidelines.